Okay, now let's discuss this practice exam for the third exam. The first problem. Evaluate the sine inverse of sine 7 pi over 8. Here we want to emphasize one property. Remember that sine function is a periodic function. The fundamental period is 2 pi. So sine of x plus 2 pi is sine x. What happens if we add the even multiple of pi, like sine x plus 2k pi? This is even multiple. You can just repeat this property every time you extract one copy of 2 pi, and eventually you will see that if you have even multiples of a pi for the addition, then you do not change the sine function. But if you have odd multiples of a pi, like for example, you just add pi, what will happen is actually like negative sine x. So here is similar. If you have x plus 2k pi and then plus pi, the odd multiple, this is also negative sine x. Okay, you can do addition, you can also do subtraction. It's the same thing, like this, sine x minus pi is also equal to negative sine x. Cosine has the same property. Cosine has the same property, okay? Then here, by this formula, you will see sine 7 pi over 8 is equal to sine 7 pi over 8 minus pi is equal to sine negative pi over 8. We know sine is an odd function, it's a negative sine pi over 8. And this moment, this pi over 8 is between negative pi over 2 and positive pi over 2. Remember that we do have such identities. Sine inverse of sine of x equal to x, but it has a restriction if x is between negative pi over 2 and positive pi over 2. You must make sure that this x is in this interval, then you can apply this identity. Now this pi over 8 is between them. And negative sine, we know sine inverse of x is an odd function. So this problem, if I, okay, all these I just review. If I write them, it will be like this. Okay, and it is equal to negative sine inverse sine pi over 8. It's negative pi over 8. Right? So that is answer here. So here, this is the answer. Okay, so this is the first problem. Second problem, evaluate tangent of cosine inverse of negative 1/3. Tangent cosine inverse of negative 1/3. Okay, so to handle this problem, first we name the inner angle as a theta, whatever letter you like. Let theta be cosine inverse of negative 1/3. We know the cosine inverse has a range. From 0 to pi, Okay, this is a range of a cosine inverse. And when you have a negative 1/3, so this theta is in the second quadrant. In the first quadrant, the cosine inverse, cosine is positive, so cosine inverse should be the in the first quadrant if you have a positive input. If you have a negative input, this is in the second quadrant. In the second quadrant, tangent theta will be less than 0. Remember that. Tangent theta is less than 0 in the second quadrant. Okay, now let's check. Theta is cosine inverse of negative 1/3. So cosine theta is equal to negative 1/3. So you're going to find the sine theta, okay? Because tangent is sine over cosine, sine over cosine. In the second quadrant, sine is a positive, so sine theta squared plus cosine theta squared is equal to 1. So cosine theta is negative 1/3, so cosine theta squared is 1/9. So this implies sine theta squared plus 1/9 is 1 is equal to 1, so it is equal to 8/9. And remember, it's in the second quadrant, sine is a positive, so sine theta is equal to 2 times square root of 2 over 3. It's a positive, if you will. I emphasize here, sine is a positive, tangent is negative. Okay, you have a sine, you have a cosine, then tangent theta is a sine theta over cosine theta. Sine is a 2 root 2 over 3. Cosine is negative 1/3. So it's negative 2 square root of 2. Negative 2 square root of 2. All right? If you do not like this process, you can also use that triangle trick. Remember, this is a theta. Cosine is a 1/3 negative, so it's adjacent over hypotenuse. By the Pythagorean theorem, we know the opposite is a 2 times square root of 2. By the Pythagorean theorem, we know this. So the tangent theta is going to be opposite over adjacent. But we know it is negative, so it's less than 0, so it's negative. So it's still negative 2 times root 2. So this is the second way to handle it. It's the second way to handle it. How do I know this is 1 is 3? 1/3. The cosine theta is 1/3, negative sign. Negative sign in this case, you can ignore it. This is a reference angle. Okay? Don't put negative numbers for the size. Okay, so first two problem. Problem 3. Solve the equation 5 cosecant theta minus 3 is equal to 2. Cosecant theta 5 cosecant theta minus 3 is equal to 2. So first we move 3 to the right side. So 5 cosecant theta is equal to 5. So cosecant theta is equal to 1. What is cosecant theta? Cosecant theta is 1 over sine theta is equal to 1. This implies sine theta is 1. So here there's no restriction about the domain of theta. So theta can be whatever number. So in the first period, there's only one value for sine theta equal to 1. So theta is equal to pi over 2. This is in one period. And then plus 2k pi. K is arbitrary integer. So this is the answer. This is answer. Theta is a pi over 2 plus 2k pi, where k is an arbitrary integer. An arbitrary integer. All right, this is a problem 3. Problem 4. Okay, we are going to verify the following equation is an identity. Identity means whatever, no matter what value of x you input, you always have equality. Okay, if you want to verify, it, we always start from one side and reach the other side. So the left hand side, let me copy it. So 1 plus secant of x, sine of x, tangent of x. All right. So secant is 1 over cosine, sine, and tangent. Sine over cosine is another tangent of x. And times the tangent x, it becomes tangent x squared. So this is one tangent of x. The second, so tangent squared. 1 plus tangent x squared by the trig identity is equal to secant of x squared. This is exactly the right hand side. So you're done about the verification. Verification is done. So you cannot first write the equality and then step by step do it. Don't do that. That is not correct because you already assume that's an identity. Here, we always start from one side and reach the other side. Okay, problem 5. Assume we have an arithmetic sequence. And we know that x3 is a 5, x8 is 15. x3 is 5, x8 is 15. Okay, so we also know that whenever you have xn, if the initial term, the first term is x1, then xn is always equal to x1 plus n minus 1 times the common difference d. Okay, so this is always the case. Now let's see how do we figure out what is x1 and what is d. So we want to know what is x1, what is d. Okay, before we figure out x1 and d, let's see what is a question. The question is to compute the sum x3 plus x4 plus x5 plus up to x10. We know that for the arithmetic sequence, the sum is first term plus the last term times n over 2. Okay, the first term times plus last term times n over 2. Okay, so it is going to be x3 plus x10 times how many numbers? N over 2. All right, how many numbers? N over 2. And we already know x3. How many numbers? Let's check. 3, 4, 5. Okay. 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 numbers, so this number is 8. So x3 is 5. x10 I don't know, it's not given, so let's put it here. Times 8 over 2. So it is equal to 4 times 5 plus x10. So we need to figure out what x10 is. So by the way here, how do I know this is, there are 8 numbers here. Of course, I give you the small number, you can just count them. But if I give you like 2021, you cannot count it. How do you know that? Remember, check here. This is from 3 to 10. You miss 1 and 2. You miss 2 terms. So it's a 10 minus 2, 8. There are 8 terms. Okay? So if you start from x1, you do this addition. there are 10 terms, but you didn't include the first two terms, so you are going to subtract 2. This number 2 comes from 3 minus 1. It's always this case. So if you have, for example, n plus 1 up to xm, how many terms are there in this sum? There has m minus n minus 1 terms. There are m minus parenthesis n minus 1 terms, because before xn there are n minus 1 terms. Before xn there are n minus 1 terms. All right, so this is a way to determine how many terms we have. All right, let's back to the question. Well, we need the x10. We need x10. How do we know x10? X10 is going to be x8 plus 2d. Remember, x10 is x9 plus d. x9 is x8 plus d, so it's x8 plus 2d. So x8 is 15, so it's a 15 plus 2d. Right? So if we know d, we solve the problem. We don't need the x1. So basically in this problem, we don't actually really need x1. Okay, so how do we solve it? D, x8 is equal to x3 plus how many d? Plus 1d, 4, plus 2d, 5, plus 3d, 6, plus 4d, 7, plus 5d, 8. I'm saying x3 plus 1d, this is x4, plus another d, x5, plus up to plus 5d, there are 5d. It's going to be x8. This 5 is 8 minus 3. So whenever you have xn, xm is going to be n minus md. Always like this. All right? Okay, so let's check. x8 is equal to x3 plus 5d. x8 is 15. x3 is 5 plus 5d. You solve it, you will get d is equal to 2. D is equal to 2. When you get d equal to 2, x10 is going to be 15 plus 2 times 2 is 19. 2 times 2 is 4. 4 plus 15 is 19. x8 is x10 is 19. So x3, x4, x8 is 4 times 15 plus, not 15, 5 plus 19. What's this? This is 24. 24 times 4, 96. Okay, this is the answer. The answer is 96. All right, so for the arithmetic sequence, if you have this addition, it's always the initial term plus the terminal term times the number of terms and divided by 2. Always like this. Okay, problem 6. Verify that cosecant theta over 2 squared is equal to 2 over 1 minus cosine theta. Okay, so the half angle formula, verify, remember this, verify. Cosecant, once again, we are not very familiar with the secant, cosecant. Whenever you see those formulas, you're going to flip them, get a sine, cosine. Cosecant theta over 2 squared is 1 over sine theta over 2 squared. And for the double angle formula, for cosine, remember cosine theta It is 1 minus 2 sine theta over 2 squared. It is 2 cosine theta over 2 squared minus 1. It is also equal to cosine theta over 2 squared minus sine theta over 2 squared. There are three formulas, and we're going to use the first part. All right, so from here, we move this 2 sine theta over 2 squared to the left, cosine theta to the right. 2 sine theta over 2 squared is equal to 1 minus cosine 2 theta, right? And then divided by 2. And then we flip two sides. And we are done. So this verification is different from the previous problem 4. It's because we start from some known identity. This one is known. It's already known, so it is identity. Start from this identity, we do manipulation, and eventually we reach the identity in the problem. Okay, so that's why this problem is always identity, identity, identity. Okay, problem 6. Okay, problem 7. Problem 7, we're looking for the cosine 2 alpha given sine alpha is equal to 8 over 17, and alpha is in the quadrant 2. Quadrant 2. Alpha belongs to quadrant 2. In quadrant 2, the hidden condition is that cosine alpha is positive. Cosine alpha is positive. So this problem, let me show you the standard way. Standard way is that you recall cosine 2 alpha, which is a cosine alpha squared minus sine alpha squared. And you're looking for cosine alpha because sine alpha is given 8 over 17. You're looking for the cosine alpha. So this is 8, this is 17, this is alpha. You use the Pythagorean theorem, you will know the other side is a 15. All right, the other side is a 15. Okay, then you get the cosine alpha is adjacent over hypotenuse, but it's in the second, negative. The cosine alpha is negative. So it's a negative 15 over 17. And then you get a negative 15 over 17 square minus 8 over 17 square. And you compute the answer. So it's 289, 225 minus 289 is 64. So it's equal to 161 over 289. So this is a standard one because when I say standard means you use a formula. You see, you need the second trigonometric value, and you find the trigonometric value based on the triangle, and reach the answer. All right, and this problem has a simple way because of a formula. Cosine 2 alpha, it is equal to cosine alpha squared minus sine alpha squared. It is also equal to 1 minus 2 sine alpha squared. It's also equal to this double angle formula. So 1 minus 2 times 8 over 17 squared is 1 minus 2 times 64 over 289. It is 1 minus, this is 128 over 289. What is it? 161. Yeah, it's 161 over 289, the same answer. It's because of a special formula. If in this problem I ask you to compute the sine 2 alpha, sine 2 alpha is a 2 sine alpha cosine alpha, then by this, I mean, if I ask you, by this problem, you must find the cosine alpha. There's no simple way. You must find the cosine alpha based on this triangle and compute it. It's going to be negative 289. This is a 30, 240. All right, so this is going to be the answer. Assume I ask you to find the sine to alpha. Cosine to alpha has special formula, so you only need the sine alpha. That's enough. Problem 8. Problem 8, we have a right triangle. We have a right triangle. Triangular, rectangular. Yeah, we have a right triangle. Here is a B. B is a 20 degrees. This is right angle. Then the other one is a 70 degrees. The side B, this is angle B. Side B is opposite. Side B is a 5. Find A and C. A usually this angle is A, and the opposite is A, and hypotenuse is C. In the problem, I should provide that IA is not a right angle. If it's A is a right angle, it's nothing to compute, right? So A is 90 minus B is 70 degrees. And then we're going to use what? Use A over sine A. A over sine A is equal to B over sine B. The law, sine law, the law of sine. So sine A is sine 70 degrees, whatever number, I don't know, but it's just sine 70. B is a 5. Sine B is a sine 20 degrees. So this implies A is equal to sine 70 over sine 20 times 5. Okay? Sine 70 over sine 20 times 5. And what is a C? C is a hypotenuse. You know, A on B, of course, C squared is A squared plus B squared. So C squared is this value, sine 70 over sine 20 times 5, this square plus 5 square plus B square. And then you take square root. Okay? Take square root. This is one possible, this is correct. I'm saying this is correct. Or you can say that B is 20. 20 is sine. Sine is the opposite of hypotenuse. So B over C is a sine 20 degrees. B over C is sine 20 degrees. B is a 5. So 5 over C is sine 20 degrees. So C is a 5 over sine 20. You can also write it is like sine times cosecant 20. And this is also correct. This is also correct. These two actually are equal. These two values are actually equal. Either way, you can use the Pythagorean theorem to leave it like this. Doesn't matter. It doesn't matter. You just leave it like this. Or you can use the trig value to get this. It's also fine. Or remember that it is also equal to C over sine C. Sine C is 90 degrees. Sine 90, remember sine C is sine 90 degrees. Sine 90 is 1. So you still have B over sine B is C. This one is exactly this one. These two things are the same. You will also have C is equal to 5 times cosecant of 20 degrees. There are multiple ways to do these problems. Okay, problem 9. Problem 9, we are really using the law of sine. we know that angle A is 10.3 degrees. Angle C is 143.7 degrees. And side C is 48.3. Well, then first you find B. Solve the angle means you are going to first find B. B is 180 minus A minus C. What is it? It's 154. 154 is 26 degrees. Okay, B is 26 degrees. Then you are going to again use this. A sine A is equal to B sine B is equal to C sine angle C. All right, so we know C, we know this value. We don't know A, we don't know B. So it's A over sine 10.3 degrees is 48.3 over sine 143.7 degrees. So A is, it's just long and complex, but not difficult. Okay, so you move this sine 10.3 degrees to the right side. It's like this. This is A. And then B is going to be, okay, let me write first. B sine B is C sine C. So B is, which is 48.3 over sine 143.7. So B is sine B is 26. So sine 26 degrees over sine 143.7 degrees and times 48.3. This is one answer, this is the other answer. And this is answer for the angle B. All right. The law of sine is very important. Okay. Law of cosine. We have side A, side C, angle B. This is 10.5 degrees. A is 6.8. C is 2.4. All right. So we solve find the B. Find the B. Yeah, this is B, not A. This is B. So B squared is A squared plus C squared minus 2AC cosine B. 2AC cosine B, right? So you get 2.8 squared plus 6.8 squared plus 2.4 squared minus 2 times 6.8 times 2.4 times cosine 10.5 degrees. In the exam, you compute this sum, but you do not compute the cosine 10.5 degrees. That's not possible. So what happened? .8. It's 46.24. 2.4 is 5.76 minus 2 times 6.8 times 2.4 is 32.64 cosine 10.5 degrees. So what is this? 52. It's a 52. Yeah, 52 minus 32.64 cosine 10.5 degrees. So B squared this, so B is going to be square root of 52 minus 32.64 cosine 10.5. degrees. That's it. Don't use any calculator to simplify it. It's not allowed. It's not allowed. Okay, so problem 11. Problem 11, find the term 6, the sixth term for this formula, for this sequence. So an is an minus 1 squared minus 3. a1 is 2. Now let's just follow it. What is a2? a2 is going to be a1 squared minus 3. a1 squared is a 4. 4 minus 3 is a 1. And a3 is going to be a2 squared minus 3. a2 squared is 1. 1 minus 3 is negative 2. a4 is a3 squared minus 3. a3 squared is 4. 4 minus 3 is a 1. a5 is a4 squared minus 3. So it's a 1 squared minus 3 is negative 2. a6 is a5 squared minus 3. a5 squared minus 3. a5 is negative 2 squared is 4. 4 minus 3 is a 1. So that's it. So the sixth term of this infinite sequence is positive 1. It's positive 1. It's actually periodic. You will see that from a2, a3, a4, a5, a6, it's going to be negative 1, negative 2, 1, negative 2, 1, negative 2, forever. All right? So this is a complete discussion of all the problems in the practice exam. So I'm going to show you the total computation. If you have any questions, send me email and I'm happy to answer them, or we can discuss with within a video. Okay, next page. Okay, thank you.